Formal charge is calculated for any molecule, and it's calculated based on the Lewis structure. So you have to have the Lewis structure first. Put that as a reminder here. Lewis is needed, the Lewis structure is first. And what it does is it calculates the charge based on the element, but not the molecule as a whole. Now there's a process, it's 4 pretty simple steps. I'll read them to you. You're going to count the bonds on that element, all the bonds. You're going to count up all the unshared electrons on that particular element. You will then add the first 2 values from the counting that you just did. And then you're going to take the valence electrons minus the total from number 3. A couple of key things to keep in mind. When you're doing formal charge, sometimes you do it on a single molecule, and sometimes you do it on a resonance series, meaning that you can have more than one possible choice. And the best option for the drawing of that molecule will be the drawing that has the most formal charge values of 0 and the nearest to 0. So if you're given a choice between like -1 and -2, the drawing with a -1 would be a better choice because it's closest to 0. The other thing is the overall charge of the entire molecule will equal the sum of the formal charges. So if your total molecule has a -1 charge, like it's a polyatomic, then each part of it has to add up in order to get that -1. Alright, so here's an example. Carbon dioxide, CO2, can be drawn with 2 double bonds or a triple bond and a single bond, and each are equally correct. Now, to determine which one is actually more likely to be formed, we have to calculate the formal charge. So we're going to need to do the formal charge for each element in both of the molecules and then compare them. So when you are doing the formal charge on the CO2 with the double bonds, these 2 oxygens, we can recognize that they are going to have the exact same formal charge because they both have a double bond and they both have 2 pair of lone pairs. So when we do our oxygen double bond, we will count up all the bonds touching that oxygen, and there are 2 bonds. We're going to add in our lone electrons, so that is 6. We're going to take the valence number for oxygen, and if you look at the periodic table and you count what group it's in, oxygen is in the 6th group, so it has a valence of 6 electrons. So we will take 6 minus 6, and we will get 0. If we do the carbon, which has the 2 double bonds touching it and no lone pairs, we have 4 bonds and no lone pairs, so when we add that together, we get 4. Carbon's valence itself is 4, so 4 minus 4 would get us a net of 0. Now you could stop and say, oh, I got the perfect answer, because it has a perfect 0 for the overall, but I want you to look at what carbon dioxide would look like with a triple bond and a single bond. So in our single bond carbon, the one that is on the left, we have 1 bond touching it, and we have 6 this is not a carbon, this is an oxygen. I have drawn it wrong, so please make sure you fix that. I have 1 bond and 6 electrons, so that gives me an overall of 7. Carbon still has a valence of 6, so 6 minus 7 would get me a -1. This carbon in the center has 3 bonds on it and no lone pairs, 4 bonds on it and no lone pairs. There's 4 and 0. That gets me 4. Its valence is still 4. So its formal charge is 0. The oxygen on the right has 3 bonds touching it, 2 lone electrons, and that gives me a 5. My valence is still 6, so 6 minus 5 gives me a formal charge of 1 here. Now the molecule on the right, if we add up all our formal charges, it has an overall charge of 0, which is what the molecule itself has an overall charge of 0, so these have to equal 0. The better choice of molecule is the one that has more zeros in it. So this CO2 with the 2 double bonds has the more formal charges of 0 and is therefore the more likely formed molecule. Alright, so here's a practice problem. I want you to calculate the formal charges on NCS-1, and I want to know which one is formed. Now, the reason I have this C underlined is because the molecule, when you draw it, has to have carbon in the center. I'm going to tell you that there are going to be 3 possible resonance structures that you need to calculate the formal charge on. I will draw the first one, and then you can draw the two other and calculate the formal charges. So we have N, C, and S. And if you do the math for your Lewis structure, N contributes 5, carbon contributes 4, and sulfur contributes 6. So I need 15, and I have a -1 charge. That means I'm adding 1. That gives me an overall charge of 16. When I plug in all of my molecules, I could have, we'll go ahead and I'll draw it in for you. I'll draw you the first one. And I'm going to have lone pairs here and here. So I have given you one of the Lewis structures, and this one has 2 double bonds in the center. The whole molecule has an overall charge of -1. So I want you to go through and draw the 2 other Lewis structures, and I want you to then calculate the formal charges and identify which of the 3 drawings are the correct and the most likely to be formed.